Hello, I'm Ruimin. Today I'm going to present my exploratory study of estimating the heart rate using Empatica E4 wristband in the vehicle environment. The wrist-based PPG heart rate monitoring has gained more and more popularity because of its portability and accessibility compared to the traditional ECG sensors, so it's more suitable in the field applications. However, PPG signals are susceptible to noise like motion artifact and ambient light interference. Various processing methods exist, but there is currently a gold standard for processing such signals. Empatica E4 is an exemplary wristband for such purpose, and it provides three outputs for the cardiovascular activity, including blood volume pulse, interbeat interval, and the processed mean heart rate. Studies validate E4 for heart rate estimation during rest, yet the signal loss significantly affect the accuracy. Empatica does not recommend using the IBI output in motion conditions and advises manual processing for tasks involving substantial movement. Our study is interested in exploring the optimal processing method for Empatica E4 signals for heart rate estimation in the vehicle environment. It's interesting because while riding the vehicle, the passenger moves very little with the exception of interacting with the handheld device. However, the movement of the vehicle can induce a light to moderate amount of motion artifacts. The data from my study came from two in-vehicle passenger datasets. In the first dataset, the Dell's EMG device is used as a gold standard for heart rate measurement reference with a sample size of 9. It includes a 15-minute on-road exposure on the urban road with human driving. The other dataset includes the use of BioPAC bioharness to be compared with empirical data with a sample size of 120, and it includes 20 minutes start-stop braking event in the autonomous vehicle setting. The participants were selected based on their sex, age, and self-reported motion sickness susceptibility, with a wide range from known to frequently experiencing motion sickness while traveling in a vehicle. First, the IBI output from Empatica E4 is examined for its quality and coverage. The plot in the left shows a clean signal with IBI detection indicated by the vertical lines, so the IBI measurements by Empatica are pretty reliable when it's available, indicating the time difference between two successive discordant notches. However, according to the plot in the right showing the missing rate in E4 IBI data across subjects, the IBI output is sparse and covers only a limited segment of the entire in-vehicle time. This figure shows the IBI coverage across time for two different subjects. The gray shading box represents the time covered by the IBI data. The availability of IBI data is highly variable between subjects despite a consistent experimental setting. This figure shows the signal quality across time for two different subjects measured by cortices. Substantial inter-subject variability is observed. The figure also shows the heart rate output from E4 proprietary and the bioharness heart rate reference. So we can find that the E4 heart rate does not consistently provide an accurate heart rate values during the high-quality signal segment. For the signal processing method, one of the ways is to estimate the heart rate by time domain peak detection and calculate the IBI to derive heart rate. The peak detection in the BVP signal was performed using the MATLAB find peak detection algorithm with thresholding, as well as two open-source peak detection algorithms, the adaptive onset detector and multi-scale peak and trough detection. However, those algorithms does not show to be effective without further denoising or processing methods. Another method for estimating heart rate is derived from the TROCA framework, which calculates the heart rate by fitting a curve to the high-resolution spectrum. A similar approach was attempted using the short-time Fourier transform spectrum and the same spectral peak detection algorithm. Although this approach involves parameter adjustment, it holds potential for precise heart rate estimation, and also the spectral analysis could also inspire processing methods in combination with time domain peak detection techniques. My next steps is to explore motion artifact reduction algorithm to enhance signal quality and continuously validate and calibrate the PPG processing methods in order to generate reliable cardiovascular metrics. Thank you.